This is part 2 of the Unit 5 mid-formative assessment. Let's take a look to see if we were right with this question over here. So we had said that 4 of these were correct and the y-intercept is wrong because the y-intercept should be written as 0, 4. That's where the line hits the y-axis. So let's see if we had the right answers here. So 4 of them are right, and the only one that was wrong was the y-intercept occurs at 0, 4. All right, I'm not doing too badly at this right now. Okay, so let's erase that and let's move on to our next question. Okay, we have a bit more of a word problem here. A dog walker charges a flat fee of $5.50 per minute. So that's basically half of $1. Which of the following equations best represents this scenario? So I always like to write out what the equation would be even before I look at the choices. So the charge or the cost to, or the amount of money that the dog walker would make would be 50 cents a minute, so 0.05, that's 0.50x, meaning x would represent the number of minutes that the dog walker walked the dogs for. And then there's a flat fee of $5. So you pay $5, and then if the dog walker walks the dog for 1 minute, it's $5.50. If it's 2 minutes, then it's $6. So I think this would be the equation here. Let's see if there's anything that matches that. So I'm just going to go through the ones that are incorrect first of all. So this one here looks similar, but it's not the same. This is not a flat fee here. This would be like saying the dog walker gets $5 per minute and then a flat fee of 50 cents. $5 per minute, that's pretty expensive. That's incorrect there. This here is pretty close, 50 cents per minute, but we're missing the flat fee of $5, so you would miss that in your calculations for how much you made. So now we're choosing between these two here, and it's not a negative slope. The dog walker would actually be making money for every minute that goes by, so it should go rise from left to right. So this would be incorrect here. We're looking for a positive slope, so this would be the best answer in that situation. Let's see if we're right. All right, there's another one. Perfect. So if you can, don't look at the options right away. The options can be misleading sometimes, especially if you glance at them very quickly. It's best to try to come up with your own answer yourself first. So a dog walker charges a flat fee, so same scenario. Which coordinate would represent earnings of $6 based on the number of minutes spent walking the dog? So first of all, in our equation we had y is equal to 0.50x plus 5. The x represented number of minutes. The y represented, well, the earnings, how much you make, the money made. So we have $6 here, so we know that's going to be our y coordinate here. And what we're basically asking is, how many minutes did you have to walk the dog for, to get a total of $6? So intuitively, you could look at it and say, well, I got a flat fee of $5. Now I'm at $6. That's $1. I charged 50 cents per minute, so it must have been 2 minutes. Another way you could have done it is you could have taken this x value, this y value of 6, plugged it into where your y is, and you get 6 is equal to 0.50x plus 5. And then solve for that. So do your inverse operations, and I'm doing this quickly. You get 6 minus 5 is 1, is equal to 0.50x. Divide that by 0.50x. Divide that by 0.50 on both sides. And you would get x is equal to 2. So this would be your coordinate here. 2, 6. 6 is the cost, which represents our y. 2 is the number of minutes you walk the dog for, that represents your x. So after walking the dog for 2 minutes, you have $6 now. That's because you had $5 flat fee plus 50 cents for every minute. So that would be $1 plus your flat fee of 5, which is 6. Let's take a look, see if we're right. Is it 2.6? All right, right on again. Perfect. So let's go on and try our next question. Similar scenario, just a different question regarding the scenario. Dog walker again. So what's the independent variable and what is the dependent variable? Select the best answer. So we know that the amount of money made depends on the number of minutes that you walk the dog for. The more minutes you walk the dog for, the more money you make. So money depends on number of minutes. So we know our dependent variable is the money. And the independent variable is the time in minutes. So money made and time, no, that's swapped. What I usually do is I fill in the blanks here, so I'll put money made for independent variable. Oh, sorry, not money made. Don't make that mistake. So our independent variable is the time, number of minutes walked. And the dependent variable is the earnings, the amount of money made. So it's not money made in time. It's not the flat fee. That's a constant. It doesn't stay the same. It stays the same. It's always 5. And we don't have number of dogs walked here. That wasn't in our scenario, period. Time and money made, that's our best answer. But let's take a look at why this one is incorrect. Well, our equation does not look at the number of dogs walked. It looks at the number of minutes and your flat fee for your total earnings, not the number of dogs walked. So this would be wrong here as well. Best answer, time and money made. Let's take a look if that's true. Yep, time and money made. Perfect. Let's go on to our next question. So here we have a graph, and we want to find some information based on the graph. How many kilometers were traveled after 120 minutes? So the 120 minutes, that's on the x-axis, and the kilometers, that's on the y-axis. So we just have to go find the 120 on the x-axis, and then see where that goes up to on the line to the y-axis. So we go up to here, that's where it meets our data point, our line there, and then that seems to occur when y is equal to 200. So 200 kilometers would have been traveled after 120 minutes. Let's see if that's true. Yep, that works. Perfect. Let's try our next question here. Similar question, but a bit different. You want to know how many minutes it takes you to travel 250 kilometers. So you know the y value this time. You traveled 250 kilometers. See where that takes you on the y-axis, on the x-axis. So this is 250 kilometers. Here's my data point there. I reached 250 kilometers after how many minutes on the x-axis here? 150 minutes. So 150 would be the best option in this case. Let's see if we're right. 150. Good. And that's just a basic graph reading skill, which is very important. Let's take a look at this question here. Which of the following is true about the data in the graph shown? It is discrete, it is continuous, it is nonlinear. The line should have been a dashed line. So when I say dashed line, that means like this. Dashed line will represent discrete data, where you can't really have, let's say, in-betweens. It's kind of like either or. It's like apple juice, grape juice, orange juice. You don't have a transition from apple juice to orange juice. So in this case, we're dealing with time, and you can have a lot of in-betweens. You can have 0 minutes, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, and even in between that, 0.5, 0.6 minutes, 0.7 minutes, and in between that as well. So the time that we're dealing with is considered continuous data. It's not discrete. It's not these categories where you can't have in-betweens. The distance, let's just make sure that's also continuous. Usually both would be. The distance here, distance as well. It's continuous data. You can have a lot of in-betweens here. You can have 1, 2, 3 kilometers, 0.5 kilometers, 0.56 kilometers. So you have all that continuation in between the different values that you see there. So it is continuous data. It's not discrete data. It's continuous. Is it a nonlinear relationship? Well, I mean, if you look carefully, you can see that it's a line. So it is a linear relationship. That's just looking at it visually. If you want to determine it more mathematically, you can try to find first differences between x and y to see if it was actually a line. But visually, it's a line here. There's no trick. The line should have been a dashed line. It's dashed if it's discrete, but it's continuous. So since it's continuous, you can make your solid line here. Let's see if that's correct. Continuous data, and that's all that was correct. Good. Okay, so let's go take a look at this next question. The rise in the data set is, okay, remember rise over run. Rise is your change in y, delta y. So you do your -6 minus 8. So we get -6, or I should say minus 8, minus 8. And we get 2. And 2 is the correct answer. So you do -6, minus 8, and that gives you 2. So minus gives you plus. You could have done -4 minus 6, and that would give you 2. Or 0 minus 2, that would give you 2. Or 2 minus 0, and that would also give you 2. So our correct answer is 2. The rise is the change in y, so that's why I did the change in the y values as opposed to the x values. What is the slope in this data set? Well, first we calculate your rise, which we already figured out, -2. The run is the difference in the x values. So we do 15 minus 16 is -1. So our rise over run would be -2 over -1. And we get 2. Oh, did I make an error there? Let me double check. Oh, yep, my bad. I did that too quickly. Let's go back and retry that here. So my rise was not -2, it was +2. So -6 minus 8. We get +2. My run is 15 minus 16. That's -1. So I get 2 over -1, -2, and that makes more sense. So errors can happen if you're not paying close attention. So -2 is correct. Let's go to our next question. So here we need to find the slope of this line. We're going to try to finish it in this video. We might have to make another video for the last question after. So we're doing our rise over run. So let's take a look. Let's choose 2 good points. So this seems to be a good point over here, and this seems to be another good point over here. I don't have to estimate anything in between. They're nice solid points to focus on. So let's take a look. So how many units am I moving over? So when I go from, let's go from here. So here I'm going up 1, 2. I'm going up 2. So my rise is 2. My run, I'm going to the left 1, 2, 3. My run is -3. So my rise is 2. My run is -3. So my slope is 2 over -3, or just m is equal to -2 over 3, like that. So it should be this answer over here. And that works. We'll finish up the last question in the next video.